Okay, so we're going to start off with, you've got a short stack of index cards in front of you with different energy sources. And I want you to put them in order, identify the top three energy sources first for overall energy in your state, and try and put the top three in order. So pick out the top three from that deck of cards for overall energy use. And, I know that I'm not expecting that people actually know this, but I want to see how you do. And so do overall energy first, and then we'll talk about that. And then do electricity, and we'll talk about that. And then we'll talk about why we're talking about that. Without doing any research, yeah. Right. So I thought Lolita and Alton were going to be sitting together, so I put the cards over on the other side. Okay. I got you. So, just take a couple of minutes to do that, and Shelley, take a couple of minutes, and you can put your best guesses in the chat when you're ready, Shelley, and the rest of us will do it with our cards. They were in roughly alphabetical order. So you're putting them in order of what are the three largest, yeah.
And
No.
the list I'm seeing
No.
online is
From the full stack of cards. Pick out the top three for total energy. I want you, from those cards, what are the three largest sources of energy for your state? And we'll just give you another 30 seconds or something. I mean, I'm essentially asking you to take a guess, because I'm guessing most of you don't actually know that. If you want to rank the whole shebang, you can do that. We can look at them. I will note that there are some things that aren't used in some states. What's the difference between which two? Hydrocarbon gas liquids are like butane and heptane and stuff like that. It is only relevant for one state. No. I think of the folks in this room anyway, it might be in Alaska too. All right, why don't we hear what your guesses are? Lauren, you want to start us off?
Gasoline, natural gas, and jet fuel.
And what state are you in?
I'm in Illinois.
Okay, let's take a look. So this EIA, which is the Energy Information website, has this beautiful interactive map of the country, and it's got nice stuff that we'll take a closer look at in a minute. But here's Illinois' energy use for 2023. Natural gas is the largest, nuclear power is second largest, and gasoline is third. So you got 2 out of 3 of those, I think. Yeah, jet fuel is like 6 or 7 or something. So coal is bigger than jet fuel. And distillate fuel oil, which is for heating, is bigger than jet fuel. Okay, so that's Illinois. Let's switch over. What did you say, Bertha? Let's go to Delaware. Okay, let's take a look. And for Delaware, natural gas is the largest, which I think is what you said. Is that right? Oh, gasoline. Yeah, and gasoline is second. And then other petroleum. Oh, no, I'm sorry. Net interstate flow of electricity, which I didn't put on the cards. That means that Delaware is bringing in electric power from surrounding states, and it doesn't. This EIA site doesn't differentiate what that is. We'll look at another source that'll give us ideas about that. And Lolita, what? And do you know what hydrocarbon gas liquids are? Or did you know before I said it a minute ago? Okay. Yeah, I was quite surprised that hydrocarbon gas liquids do indeed make the list in Texas. It is the second largest energy source for 2023 after natural gas. Natural gas is the biggest source of energy in the country, in part because it's a flexible fuel. It can be used for generating electricity as well as heating homes and some industrial processes and stuff like that. So for Texas, it's natural gas, HGL, hydrogenated gas liquids, and gasoline in third. Okay, so now do the same thing, but just for electricity, and take a minute to do that. So pick out the three largest sources of energy for your state for electricity. Oh, and I didn't ask Shelley. What's your answer, Shelley?
Oh, I said coal, hydro, and natural gas.
And you're
And
identifying it as an Arizonan now, is that right?
yeah, so I was totally off on coal. That's Colorado, I guess.
Yes.
It's
Well, coal is
gasoline,
still in the
natural
mix. The
gas.
natural gas is number one. Very close between gasoline and nuclear power for number three.
Yeah,
I think
I
gas
don't
is
even know where they've got nuclear power plants, but
no,
something.
there's a big one in Arizona. I don't.
It's not you, Shelby.
Yes, you're right.
Closer to me.
Yeah, yeah.
Oh,
We'll actually we can look at that in a few minutes. But so now do the guess for electric power, and we'll take a look in a moment. And are you ready with your guesses? Lauren, you want to start us again?
No, okay. Uh, so Illinois, um, and I'm not sure I have my top four potentially nuclear, just based on last comment, and then coal, natural gas, and non-hydro.
Let's see. So nuclear is number one. There you go. Very, very good. Awesome. Awesome work. Okay. And now let's go to Bertha again. Okay. And I believe it's almost all natural gas. Yeah. It's almost all natural gas. Um, and then non-hydro renewables for number two, and and coal is listed there, but it's so tiny that it doesn't even get a thing. And Lolita. Okay. You're all gonna be surprised here, I think. And this is it's kind of weird that they give the last year for total energy, but the last month of available data for electricity. And for Texas, you got more electricity from non-hydro renewables. Almost all of that is wind in Texas. Texas is the largest producer of electricity from wind in the country. It is not per capita and so forth, but it is the largest. And natural gas is almost tied, but I think this is, yeah, it's very, very close to a dead heat, and then some coal, and then some nuclear. Um, and I will note that I was surprised to see the hydrocarbon gas liquids for the total energy in Texas. I'm pretty sure it's the only state that produces very much from hydrocarbon gas liquids. I'm a New Yorker. New York has no coal anymore, and hasn't for at least 3 years, and maybe it's 5 years since the last coal-fired power plant shut down. And the change in the energy system is very fast. One of my favorite stats is going to look at Iowa here. And I learned the alphabet down. And for Iowa, they get 60% of their electricity from wind. A lot of windmills, and almost all of, the overwhelming majority of their electricity is coming from low carbon sources, which is pretty remarkable.
So,
Yeah. Yeah, so does Oklahoma. Yeah, and throughout the Midwest, there's a whole lot of wind, and taking a little bit longer. Let's leave Iowa and go to one of your states. We'll go back to, well, where should we go? We'll go to Delaware. Yeah, let's not go to Delaware. Delaware is boring because it's almost all natural gas.
What about Arizona?
Okay, let's go to Arizona. And I forgot to ask you again, Shelley, what's your guess for Arizona for electricity?
I said natural gas, nuclear, and hydro, but then again, they do a lot of solar here, so
Mm,
foreign.
So natural gas is number one, nuclear is number two, a very close number three is non-hydro renewables, which is going to be wind and solar. Yeah. And hydro is number four, which
Hey.
before,
Hi there. Hi, I'm in the car, so I'm not holding on to the phone. Can you hear me?
yes.
Sorry
Yes.
about that.
So who is that?
I'm calling you back.
Hang on a second. That's Rusty.
Oh, okay.
She says hello. I gotta take this
Hello.
call.
Hello, hello. That was confusing. Right, right. Yeah. So, if your knowledge of the energy system is 3 years old, it is out of date. And so let's take a look at back.
are there
Yep.
any parts that you have that are like this, but with definitions that can be printed out?
Well, you can,
pictures, or
yeah,
you make-
you have to make them. Yeah, if I had those, I would have brought them, but
Well, that's something we
yeah.
can
Okay, cool. Yeah.
do.
Yeah, so where was I going to go here? So this website has so much data. It'll make your head explode. If you like maps, it is super, super cool. Let's actually go to Washington since that's where we're sitting right now and take an exploration around Washington. You want to take a guess for Washington's top 3 energy sources? Anybody want to take a stab at it?
Nuclear.
Hydro is, I believe, hydro is number one for electricity, but natural gas is number one overall. So Alton, we're looking at the question of what are the largest energy sources in your state, and picking out and then following up to see what they are. And in Texas, it is the 2 largest sources of energy overall are, what did we say, natural gas and hydrocarbon gas liquids, which is weird. I think Texas is the only state where that's up on the list. That's butane and heptane and stuff like that. So that's a byproduct of the refining process that is also, a economically important set of substances. But it does make Texas is unusual in a lot of ways. Now we're talking Washington State because that's where we're sitting. So for Washington, natural gas is the largest source of energy overall, with gasoline in second and hydropower in third. And for electricity, hydro provides the overwhelming majority of the electricity in Washington State. And again, you'll note that coal is almost zero. So why is it important to talk about this? And why did I ask you what the largest energy sources in your state are? Yeah. Yeah, the geography of energy is fascinating. And I think my biggest reason is that a lot of people have very strong opinions about where their energy should come from, but they don't actually know where their energy is coming from. So I think they ought to learn that. Yeah. Yeah. Yeah, Texas is weird in a lot of ways. It's got its, as you know, right, right, yeah. Um, yeah, and you have a grid that is not as tied into the national grid as any other state. And, that's fine as long as your grid is working. Because if there are problems within the state, in other states, you can bring in electric power over state lines through power lines, and not so much in Texas because it's a more isolated grid. And I think that that makes me want to jump ahead to the EPA power profiler, which is down a little bit in the agenda. But we'll take a look at this too, which this looks at regional grids, which you can see this interactive map. The Northwest is a big regional grid. Texas is pretty much its own grid. New York State, where I live, is kind of weird in that it's got three separate grids, one for upstate, one for New York City and Westchester County, and one for Long Island. And those three regions are pretty different. As a New Yorker, I will click on mine and you can see an upstate New Yorker, I should say. Here's the national picture in comparison to upstate New York. And so nationally, we're getting 43% of our electricity is from burning natural gas. That is a huge change from 10 years ago or 15 years ago. Coal use peaked, I think, in 2008, and we are using less than half the amount of coal that we were burning at our peak just 17 years ago, I guess now. And that has led to a 40% reduction in emissions from electric power generation over that time, because we've stopped using coal and we've replaced it with other stuff. Usually I spend more time on this and try and force it out of folks to say, why are we down 40% in emissions? The short answer is because we've replaced coal with other stuff. The other stuff is complicated because it's not just one thing. It's mostly natural gas, and per unit of energy, so per kilowatt hour or whatever, you get about half the emissions from natural gas as you do from coal. So replacing all that coal with natural gas is less bad for the environment, but still bad for the environment. And we've also replaced an awful lot of it with wind. And in upstate New York, by the accident of where I live, click back. If I click back, it will give us these graphs comparing, this bar graph comparing CO2 or SO2 or NO2, and you can click on it and it'll order it. And you can see that upstate New York has half the carbon pollution of the next lowest state. So upstate New York by far has the lowest carbon grid in the country. Why does upstate New York have the lowest carbon emissions in the country for its electric power generation? What do you think? What? Well, this is per capita, I think. Well, this is just electricity we're looking at. Yeah. So why is our electric grid in upstate New York the lowest carbon emitting grid in the country per kilowatt hour? And say that again. Niagara Falls is a part of it. We get about a third of our power in upstate New York from Niagara Falls. And we get about a third from something else that's low carbon. No. Nope. We get about 6% from wind. What else is low carbon for electricity? Nuclear. Yeah. So we have, so we get about 2/3 of our, about a third each from hydro and from nuclear, about 6% from wind. And if we go back to the back to here, you can see we get, so there's 32% from nuclear, 32.9% from hydro, 25.5% from natural gas, 5.5% from wind, and some biomass, which is mostly burning garbage, which I don't know if that's really biomass, but and we're up to 2% for solar now, which is a big change just in the last couple of years. So let's see what else. Let's take a look at. Right. Yeah, yeah. It's a complicated story. So here's what Texas looks like. And this is the Texas regional grid, a little bit different from state lines, but not a whole lot different. So 40% of your electricity is coming from natural gas, over 20% from wind, and so you can explore around on this. You're still getting over 10% from coal, but that's way, way down from what it was, and you get.
Line grid is national grid besides like the
Oh, yeah, they are pretty similar. Yeah. Yeah, and it's got quite a bit more wind than average, but and quite a bit more solar. So nationally, solar is at 4% now. That again is a big change, and I think the previous year's data, I think this is 2023 data now. Yeah, the previous year's data, I think solar was less than 2%. So going from looking at the wrong one. I don't think you can do that here, but there is a place for it linked in the resources. So that's a good segue. But you can also, before leaving here, I should also point out that you can look at sulfur dioxide emissions and nitrous oxide emissions, and you can look at the differences between different regions of the country. So the Northwest gets a lot of their electricity from hydro, the upper, the MRO West, well, I don't know what that stands for, but they're still getting a fair amount from coal, but a lot from wind. So you can explore around and see. So Delaware is in this one, right? So natural gas is probably from that interstate flow of electricity that we saw on the EIA site. That's probably mostly natural gas and nuclear, since that's what the regional grid shows. Okay, so Alton asked about, what did you just ask about? Oh, year to year. So let's see, where is that? No, it's here somewhere. Oh, the energy flow charts. So this is a super cool site. So here, this is from the Lawrence Livermore laboratory. You can look at these, what are called Sankey diagrams, which are very, very interesting. Note that the thickness of these boxes is not to scale, but they try to be to scale in the middle of the graph and maybe at the end, I'm not sure. But our total energy consumption in 2023 was 93.6 quads. That also is actually down from a few years prior, and it came from these sources. So petroleum provides about a third of our total energy demand. Natural gas provides about a third, and then we've got other stuff rounding that out. Nuclear and coal were both at about 8%. And for these, you can look back at previous years. So let's jump back to 2005 and look at the US. Oh, and do I need to, I guess I gotta select US here or something. How do I get there? I've done this. I know I've done it. United States. One should give it to me. Huh. Crud. Huh. Well, let's go to Texas, I guess. Since that, nope. Let's go to Texas here. And let's look at the most recent one. And Texas, Texas, Texas.
Looks like the US data only goes back to 2010.
Ah, thank you, thank you. Let's try that. All right, so let's get that out of there. There we go. All right. Oh, come on now. Oh, and that's. It does not have the US as a whole here. All right. Yeah, we'll take a look at Texas. So here's Texas in 2010. So 12 trillion BTU, and 1% was from solar in 2010, or not 1%, but rather 1 trillion BTUs. And 430 from nuclear. So again, these are not to the size of these boxes is not to scale. And let's take a look at it for 2023. And 2023 might not be, let's try 2022. There's 2022. So it was like 4 for solar or something like that for 2010, right? Now it's 87.4. And you can see petroleum has shrunk. And so you can explore it. I guess the data set's not quite as there as I was hoping. But you can look for those changes over time. And there are places within the EIA site. If we go back here, did I put those questions somewhere else? Let's see. So a question here. In what year do you think between 1960 and 2023, New York State consumed the most gasoline? What do you think? And this is an example of the kinds of questions you can investigate on the EIA site. I will tell you that I guessed that it was 2023. That is incorrect. You are starting with the wrong digit. 19. Nope. So you can click here. Nope. So here's gasoline. There are years. So we're scrolling through looking for the biggest number. There's 760. And it's shrinking, 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 sort of holding steady, shrinking, shrinking. So it is 1970. Is it 1970?
Yeah, 1973. That meant 762.
Oh, 762. Yeah, it's 1973. Yeah, that surprised me very much. So why does New York State not use as much gasoline as it used to? This is total gas use in the state. It's in trillions of BTUs. More people not using cars because of the population density in New York City. So most people in New York City don't have cars, and they are regularly adding new subway lines. It's not like every year a new subway line opens up, but it gets easier and easier to move around by subway in New York City. And about a third of the population of the state is in New York City. And an interesting sort of free associating a little bit. There are 2.1 million public school students in New York State, 2.4 million public school students in New York State, K-12 students. 1.1 million of them are in the New York City district. So that gives you an idea of the population distribution. But let's go back here. And you can look at the answer for the US, which I just looked at this the other day and I have already forgotten. So for the US, we're generally going up and kind of holding steady and then going up a little and then holding steady, going up a little, going down, going down, going down. So I think there's a 17th. 2006 was the peak gasoline use for the US. So why don't you just take a minute and poke around on just this chart for a minute and look at it. So there's natural gas, there's jet fuel. So just take a minute and take a peek, or you can click from the site and go. Oops, that's not the right place. Where is it? This one. And here you can go up and change the state to your state if you want to explore that data for your state. Yeah. Going much longer on this than I intended. That's all right, I think. Yeah. And just why don't you take a minute and then find something interesting and share it with us. Take like 15 more seconds to pick something out. All right, who's found something interesting?
California was interesting in that it continued to grow all the way through 2010. It went back, like less gas being used, and then it jumped up again. And it's only in the last 5 years, probably since people went remote, that
Yeah, we'll actually
gas usage went down.
yeah, we will take a look at, here we are. So here's US gasoline consumption over time from January 1945 to April of 2025 for the US. And I think it's a fascinating graph. And we can go a lot of places just from this graph. What jumps out at you? COVID. COVID is very, very obvious. So this is April of 2020. And note that we have not gotten back up to the pre-COVID levels, and I don't expect that we will, because EVs are growing. Not everybody has returned to the office and so forth. So there are a bunch of reasons. There's a lot of, I think there are a lot of really interesting places you can go with this graph. And Lolita, what did you say you had found? Yes, yeah. So Texas is both the largest user and largest supplier of energy for the country. one or two other interesting tidbits.
So I was looking at the Texas, I think it was talking about the car gas data.
Yeah.
I was looking at how that number keeps going up.
Yeah.
Yeah, you know, it's the year COVID, I went down just a little bit.
Uh-huh.
Just, like,
Yep. Yeah, Texas is an anomaly in many ways, as I'm sure you know. All right, let's see. What do we have next in here? All right, so there, oh, and let me do another. So I'm looking at the Washington State page in the state pages, and looking at the map at towards the top of that page. And the map is super, super cool as well. We'll go to full screen for it. And pretty much you can click on any piece of major energy infrastructure in the country and look at data for it. So these symbols are water droplets, they're hydropower plants. And you can click on any one of those and see its generating capacity. So this is a 4 megawatt-ish hydro plant. I don't know where the Columbia Dam is for the largest one in the state. This is a wood waste plant. So burning wood chips or whatever, and that's 4.5 megawatts. And this is a solar array. And it's 5 megawatts. It's just totally by chance that I'm clicking on things that all have about the same generating capacity. This is a natural gas plant, and it's 600 megawatts, so much larger capacity plant than the other ones that I've clicked on. You can see the keys. You can also turn on and off things individually. So I can turn off all the power plants. And then if I'm looking at a particular one that I want to see, so coal-fired power plants, there aren't any in Washington anymore. So that was not a great choice. Oh, why aren't they turning on? What's the deal here? It's weird. But you can go to any of these power plants and click on them and view their generating data for the duration, either since they opened up or since 2000, whichever is last, first, whatever. So you can do that for any major piece of energy infrastructure in the US. It is super cool. And again, going back to the question I asked of, where does your energy come from? This map, you can go to your county or whatever and see what power is produced in your vicinity. Pay good attention to the size of the generation, because when we look around, I'm sorry about my voice, it's irritating. But you can see the entire country. There's a way to turn off the mask that I don't remember, the state mask, but you can see the entire country has lots and lots of stuff going on. And there are now solar farms everywhere, but they're mostly pretty small. They're mostly on the order of a few megawatts. Whereas if we go into New York State, the state I'm most familiar with, let me switch to New York State because I know my way around. Yes, thank you. I've got a glass. So I'm going to switch state and go to New York. Thank you very much. And the largest power plant in New York is the Robert Moses Power Plant at Niagara Falls. And if I click on that, its generating capacity is 2.4 megawatts. or gigawatts rather, 2.4 gigawatts. So 2,429 megawatts. And that is the largest power plant in the state. The second largest is the Ravenswood Generating Station in Queens. And that is, it's actually a dual-fired power plant that can run on either natural gas or petroleum, but it hasn't burned any petroleum to speak of in several years. And you can see all over the state, there are solar farms, but you click on any one of them, and I think the biggest one you'll find is maybe 30 or 40 megawatts. Most of them are less than 5. So all of this solar adds up to like 2% of the state's energy demand.
Is that common solar?
Yeah.
Across the country,
Yeah.
are there larger scale ones?
There are larger scale ones. There's that big one
Yeah.
in Arizona that's that has these mirrors focused on this thing. I forget the name of it, but it's a pretty cool plant, and it's produces a lot of electricity. But the bigger, and interesting, let's actually go into another place. Oh my God, it's 4:47 already. Let's see today. So this this looks at the changing energy system to some degree, and we're just going to take a quick look at one piece of it. I originally created this presentation in like 2010 and updated it a couple of times. And then it's been sitting dormant for a little while until I updated it earlier this year. And it's called There's No Such Thing as a Free Megawatt. And part of the point of it is that there is no the only truly environmentally friendly energy source is the one you don't use. If you are producing energy at a large scale, it's bad for the environment. And the first book that I was a co-author on is called The Science Beneath the Surface, and it was about hydrofracking in the Marcellus Shale. And we did a lot of work on fracking education, sort of, that was funded by the National Science Foundation, and we promised not to advocate for or against, just try and do our level best to help people understand the energy system. And I was often asked, well, what's the real answer? And part of my response, another question that I was asked is, what's the most important thing to know about the about hydrofracking? And my answer was the broader energy system. You need to understand the broader energy system in which we're operating. And now that funding is done, I'm allowed to speak my mind a little bit more. Hydrofracking is bad for the environment. It's not as bad as coal, and it's not as bad as okay. 5 minutes left, she says. All right. So we're gonna fly by that. I'm just gonna pull up a couple of things. Let's actually. I think as educators and politicians and journalists are guilty of this too, we want to simplify the complex, and that's an appropriate thing to do a lot of the time. But the reality is the world's a complex place, and sometimes it's appropriate to complexify the seemingly simple in a friendly way without forgetting about the importance of the simple, and let's use a lot less energy. And we're going to fly by, that. So this is looking at one moment back. So this is looking at where we got electricity from in 2012. And the black mottled stuff is a picture of coal. That is natural gas. The yellow is nuclear. You can see that throughout the Midwest, there's a whole lot of coal. The Northwest has a whole lot of hydro. And this is looking at the same data sources in 2023, most recent data available. And we are using a whole lot less coal than we were back then. And you can explore around on this. I'll put the link in the chat or in the agenda after I turn things over to Carla, but I'm going to take another minute or two to go over here and point you to a talk that I've given a lot, and I'll point you to the resources for this. I would have brought that block of graphite with me, except I was just doing carry-on and they don't like things like that. So I have this 2 by 2 by 6 inch block of graphite, and graphite's pure carbon. How do you think a 2 by 2 by 6 inch block of carbon that weighs a little over 1.5 pounds, how does that compare to the amount of carbon in a gallon of gas? Is it a lot less, about the same, or a lot more than the amount of carbon in a gallon of gas? What do you think? You are correct, sir. Very good, very good. Most people get that question wrong. I usually spend 20 minutes before getting to the answer for that. And I also give Pee Wee some credit here. I'm going to jump way ahead in the presentation. And skip through all that. And let's take a look at what do you get when you burn gasoline. You get carbon dioxide and water and energy, of course. And I'll note that I made this in Keynote, which is Apple's answer to PowerPoint, because I like the animations better. And so here at the top of the page, we've got octane, the largest part of gasoline, plus 12.5 O2. And I know that I'm cheating to use a half an O2 to make the animation work a little better. And we're going to animate this combustion reaction. There are oxygen molecules. There's our octane molecule. We give this a spark and we get 8 CO2 and 9 H2O. And when we look at this, there's our carbon dioxide molecules, there's our water molecules, and we look at the 8 CO2 molecules, and they weigh a bunch more than the octane molecule because we took oxygen out of the air to make the carbon dioxide. And that means that the resulting carbon dioxide from burning a gallon of gas that weighs about 6 pounds is a lot more than the weight of the gasoline you started with. You get 19 pounds of CO2. And that's a surprise to most people. And I'm going to fly through this too, but you've got the links to this. And I do actually have balloons with me, but we don't have time for it. So I have people blow up a balloon to about a gallon size and think about how many gallon size balloons it takes to hold 19 pounds of CO2 that you get from burning that 1 gallon of gas. Anybody want to take a stab? It's about 1,100 balloons. Yeah, yeah. You teach some chemistry? No.
Is it? Don't say that.
Yeah. Well, it's not surprising. So this is 100 balloons. So we got to do that. There's 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100. And that's for 1 gallon of gas. And you can do the chemistry to think about how many balloons worth of oxygen it took to do that. And we do that 376 million times a day because that's how much gas we burn on the average day. So more than a gallon per person per day. And that should make you say, wow. And pardon me? Right. Yes, yes, we do. So that's 7 billion pounds of CO2 just from burning gasoline. Liquid transportation fuels are responsible for about a quarter of US emissions. And you should be scared and astonished by that. But I will also note that I think it's okay to scare people. It shouldn't be your end point. But if they're not scared, why would they do anything? If they're not worried about it, why would they do anything? And you don't want to leave them a crumpled mess. You also don't want them so freaked out. You want to get in between the freak out and the lethargic depressive state. And there's psychology behind that, where I'll show you one slide on that in a couple of minutes, and I'm going to blow by
We're
it.
T-minus.
Yes, I know. You know me better than that. So the best way to address anxiety in general is to address the source of the anxiety to get to work on the problem. And working in community further reduces anxiety. So you want to get people working on the problems. And I will just do a tiny bit, one more half a thing. There's our answer. For the gasoline amount of carbon in a gallon of gas is that. And I meant to order a 6x6x2 inch block. And my sister calls that fortuitous incompetence. If I had a block that big, people wouldn't be able to wrap their heads around it to start. So it's fortuitous that I got a block that's a third of the intended size. And we will just note that you don't want to put it in the air in the first place, but if you're going to take it out, wood's the logical thing to do. So you need to grow 11 pounds if there's 5.5 pounds of carbon in a gallon of gasoline, and that's of a 6-pound gallon of gasoline, 5.5 pounds is carbon. And it just so happens that an 8-foot 2x4 weighs about 11 pounds. So an 8-foot 2x4 has roughly the same amount of carbon as a gallon of gasoline. And we are not growing 374 million 2x4s a day in the US. And I will stop there and hand it off to Carla.
And so the next activity that we're going to do in a few minutes was developed for a calendar that's part of Earth Science Week. So Lauren is going to share a little bit about Earth Science Week. Do you want to bring up the Earth Science?
Yeah, you bring up the Earth Science website, and I'll talk behind you so Shelley can hear in the recording. So Don shared a lot about energy, and for AGI, we facilitate Earth Science Week, which is the second week of October every year. There's a theme every year for Earth Science Week just to help kind of focus the celebration. But really, the point of Earth Science Week is to share resources and to promote all of the good work that geoscience organizations are doing. It's just earthsciweek.org.
Yeah.
And so Earth Science Week, AGI compiles a toolkit of materials. We create materials, www.earthsciweek.com.
Oh, .com.
Yeah, or .org, you're right, but www. And so we compile materials, we create materials, there's posters, if you click on the toolkit page there, top, thank you. So that's an image of kind of this year / last year's materials, but it's a physical toolkit. It gets mailed out. It's in the folder. There's posters, there's bookmarks, there's so many different things inside of it. Activity pages, you can see the list there, that all these different organizations contribute to. So you can scroll all the way up and then go to maybe support and then to partners. Oh, sorry, go down right there. Yeah, so then you can see all the different organizations that are involved in Earth Science Week. And so there's a lot of different partnerships that occur, whether it's through webinars or contests or the toolkit. There's, again, AGI is just hoping to promote all the work that people are doing. And so that's free for educators, free to order. You do have to pay for shipping if you're paying for it by yourself. If you go to there's a lot of organizations that distribute them for free, such as at NSTA, USGS, PRI does. Many organizations that are member societies and partners with AGI are able to do that. You can go to the webinars. So every year for Earth Science Week, AGI does not host events for Earth Science Week. We let everyone else across the country do it, and I'll share a map of that in a second. But one event that AGI does put on is the webinars, which are during their Science Week. And if you click on, keep going down to past Earth Science Week webinars, right there. then you can see all the past Earth Science Week webinars that you can use for your own education. There's snippets that you can pull for your students, but there's lots of different topics that you can kind of explore more in depth. And then more related to educators, if we scroll all the way up to contests, every Earth Science Week, there are contests. There's a photography contest, video, visual arts, and write an essay contest. The photography and the video are for any age. Visual art is for elementary students, and then the essay is for middle school students. But if you scroll down a little bit, you can see the details. Also, this year it's going to be recorded. It's going to stand up forever. This year, we're most likely going to be working with Word Scientific to do a teacher contest on lesson plans. And so keep your eye out for that, because that's still in the works, but likely you could also submit a lesson plan related to energy as a. So you can kind of view the contest history, but also the contest. The due date for contests are the Friday of our Science Week. So a lot of middle school teachers, elementary school teachers will spend their Science Week with their students doing the essay or the visual arts contest and then submitting it by the Friday of our Science Week. One last thing before Carla goes is if you go all the way up to the top under Toolkit, and then down to the online toolkit, a lot of these resources are available. Sorry, up a little bit, right there. Are available on our online toolkit. And if you scroll down and click there to the activity calendar, every year during our Science Week, we compile a calendar activity calendar for our teachers and whoever else. The top you can see is an activity by an organization. So that's ESIP's month. And then you have the calendar grid. So you can use it as an actual calendar. It has Earth Science related dates on the bottom highlighted, including conferences. And then again, just a collection of activities related to the year's theme, along with other links and background information. So we just try to throw as much at you as possible without overwhelming you. But with that in mind, this year's July activity will be, Carla had written for ESIP. And so that will be featured in the activity in the calendar this year, which will be coming out sometime in August/September. Related to the theme, which I don't even think I shared, is energy resources for our future. And so a lot of the resources Don shared are going to be part of PRI's entry to the online Earth Science Week toolkit. And then Carla is going to kick us off with the July activity.
And sometimes we work in parallel universes. So a lot of the things that Don showed you, and he's been thinking about for years, I didn't know. I just dug into all this stuff to write this activity for ESEP for the calendar. So we're going to use some of the things at EIA. This activity here will appear in the calendar, and it will also be available for you digitally so that you can actually click on links. But for today, if you flip to the agenda for a second, we put the links that you're going to need in a minute on our agenda page. And I think it's up a little bit. I think, Lauren, you put it right under the description or something. Yeah, right. So right there on the agenda page, you want to have your agenda page open for those 3 links. Those are the 3 places you're going to go to. And then in just a minute, when you got that up, Donna's going to put the activity back up, which you can see if you're in the Zoom space, you'll be able to see it. You can't click on these links up here, but you can click on we just copied them and put them out there on the agenda.
I can click on.
Yeah. So oh yeah, that's true. You can. So this is meant to be written for the student. So middle and high school. So this is an activity you could use directly with your students. The introductory paragraph kind of sets it up, but as it is getting late, I suggest rather than individually doing this, that we just all collaborate and sit around and go through it. So, read it. It's only about 4 or 5 steps. This was I want to say 5-page activity when I wrote it and got into it, and you're limited to 1 page for the calendar. So wonderful folks at AGI condensed it, but it still has the sort of basics of what this activity could be. And I'll just point out the graph in the upper corner there is CO2 emissions over time, which is really fascinating because you see that same, what was going on in the 1970s there. That's the oil, crash. So CO2 emissions are related to our energy consumption big time. And, we have been reducing energy, but I won't give away the story of why that thing is going down. And just I'd like for you to try and go through this activity and then we'll debrief a little bit. So I recommend you sit next to each other and click the links, and the first one's gonna be very interactive.
I can scroll down just.
Yeah, so use an interactive graph to explore US energy consumption. And so Don, if you click that, people will get started. Oops. There you go. I love this one. Hover over it, they can see that. If you hover over it, you can see actual data on that thing.
The other question. On the board, there's some questions.
Too much, too much. I will be right back.
Okay, no. Just like tap it if I need to. Do you guys need to see the CO2 graph again?
You can have it up.
Yeah.
Oh, okay.
Need the questions.
Okay. Well, that, the one was emissions up in the upper right corner. And then the other thing is the energy consumption. So the, one of the questions is to compare, yeah. Compare this with the one that has coal and the different, yeah, so compare those two. I'm gonna print it out, but I would have been violating policy. They haven't released the calendar yet. They're seeing pre-publication material.
Yeah, you guys are first. Where you can see it.
Yeah. Yes. This is the CO2 over, you know, like, this is.
and all the whole time have really conducted increasing. But what 2020 on the 2020. Yes, but 2020 it went down. Yes. And the carbon dioxide went down, but the coal natural gas not totally gone up in 2019.
In the right, coal went during this time, coal went down, right? Yeah, coal went down.
Now,
Well, what's happening here too, after COVID, like, who's president?
last night.
No.
Coal started to go up again. Plus people started moving around to get at. Who likes coal? Not like who people shop.
Right, so, you know, so there's, these are not making much of a difference, now look at it, part of this is people driving again and whatever. But this is an interesting, coal going down is big, you know, it's really reducing the CO2 emissions, right?
Yeah.
You know, hopefully, the matter will be, you know, brought back to fight. But no, there's going to be very interesting what happens. So that's the first set of questions.
Well, the internet is the travel restrictions. Getting raised and so much of the federal work.
Oh, yeah.
These are just like removing regulations on a whole bunch of stuff. We won't know if we have healthy air, healthy, you know, clean air, clean water. We're gonna know any of that next few years. Yes, question.
Looking at 2005.
Yes.
What happened to start to slow down?
Well, there was a financial crisis in 2000.
Yeah.
Also, doing a lot of trying for it was very, people were financially in dire straits, and the housing crisis happened. That's,
Okay.
so that unlocked. So, see them, I'm not sure the next.
Yeah, sorry.
The next.
Sorry. Let me, can I just share a one quick related thing that, this is, so we were just looking at total energy.
Yes.
This is electricity. And, right now we are, oops. The nuclear is yellow, right? Yes. So the blue here is other renewables, mostly wind and solar. And that is right now, as of a month or so ago, the second biggest energy source for electric power generation in the US. So we are getting more electricity from non-hydro renewables than from anything except for natural gas. And that happened briefly in 2024, but if you look at the trends, that is gonna maintain second place. If assuming those trends continue, it's gonna maintain second place for a while and hopefully eventually become first place. It's seasonal. So, yeah, so natural gas, we use, yeah, so, we use more electricity in the summer than in the winter. So that's most of the, yeah, and you can, yeah. Yeah, and you can, you know, shut off the various things and look at them individually and so forth, but that is, in my opinion, super cool. Okay, so we are here.
So we move it to the left and I'm not sure, I think we went through the first part there. Consider the major things, describe the trends. Is the bit.ly CO2 by, okay, that's the one you guys did. No, I don't think so. Click on the CO2 by energy source. That the one they did? Yeah, yes, we just,
No, this is a different,
oh, this is a different one. This is emissions by energy source, and the other one was,
primary energy consumption by source. So consumption versus emissions.
Right.
You want me to flip back to the activity?
Sure. Here, I think we just kind of did that. It's
Yeah.
CO2 emissions, but it's,
Yeah.
yeah, okay. So the US is the largest per capita CO2 emitter in the world, and then there's the chart. I love this. So this may seem kind of complicated, but it's worth kind of just taking a minute to look at it because it's a, they call it a spaghetti graph. But if kids can learn to interpret this kind of a graph, it shows you from the source to the end sector. So transportation, the uses, what we're doing with it. Yeah, you can blow it up a little bit.
It's the full screen button.
There's a good descriptor too.
And your full screen.
So someone follow one of those arrows along and see if you can give a statement of what that is saying.
Our source, biggest source for energy. Petroleum, right, followed by natural gas, and then and then over here we have the what we produce most of our energy for. We go around from place to place, and what kind of transportation do you think that is? It's all the cars. I mean, initially people kind of think, oh, it's airplanes, they contribute, but it's the cars. And then the next biggest is, you know, followed by commercial, and there are definitions on the next page of this that kind of define what the difference is between, say, commercial and industrial. But now, see if kids will be able to follow across. What's it? Somebody give me a statement. Any one of these arrows, choose it and say, what does that mean?
%, told me our biggest source is they use on transportation.
89%. Yeah. So it's this really kind of cool graphic to get kids to paint it, think about, gives you a lot of information to know initially that's really okay, petroleum, and it's transportation, most of transportation. And we have another, that's what the last people call, you know. I mean, here this is 10%. I think it's almost. Here, yes, 9.
So for the folks on Zoom, they are discussing what the arrows show. They're following arrows and talking about how the petroleum, for example, 70% of the petroleum is used for 89% of transportation, the transportation sector's energy. It's also very much worth noting how much energy losses there are in the electrical system. There's other ways of looking at energy loss throughout the energy system too.
So we are seeing these sources produce electricity and then in turn provides power to these entities.
And very importantly, inside that box in the middle there, that black and gray box, 59% of the energy that goes to electricity ends up going off as waste heat. So
Don, can you answer that question?
what's the question? It's pretty much going off as heat. Yeah. So there are, so traditionally, coal-fired power plants, for example, traditional coal-fired power plants would have just a whole lot of waste heat. More sophisticated, newer ones, are often combined heat and power plants where they use the heat for something. And natural gas plants also, again, the older ones, probably just have the waste heat go off to the atmosphere. Cornell has what used to be a coal-fired power plant on campus that in 2009 was converted to natural gas. And the waste heat from that is used to heat the buildings on campus with radiators that connect into the power plant. But there is waste, there is loss at every point in the system, and most of it's going off as heat.
Even a bell ringer, like if I just wrap up and say write 3 sentences that are true, and it's like just being able to read it.
There's one of these, this is, I think this is one of the top, I think it's like.
Yeah, it's 2023.
Sure, that they put it out, it takes them a few months to read the content. I mean, that is back.
Yeah, and it's pretty similar to the Sankey diagrams that I pulled up earlier. That's a British thermal unit. And a British thermal unit is, if I remember correctly, I think this is right, about the heat you get from one match, from a matchstick. Is a whoppingly large number. Yeah, and I'm gonna shout out in here that an activity that I do about helping people understand scale, because we suck at understanding scale, is asking folks to, I put 0 on one end of the front wall and a Post-it note and a trillion on the other, and ask people to go up and put where they think a billion goes between 0 and a trillion. And they're horrible at it. So there's the answer, is that everything should go in the first 1/1000th of the distance, because 1 trillion is 1,000 billion. And this is what the answers tend to look like. So this is a GIF. People put the answer, and I have done this probably 100 times with different audiences, and it almost always looks like that. Yeah.
The same thing happening in the pyramid. From when we go from one to the other level, 90% lose.
Right.
Yeah, and I was over lunch where I was talking about firing fire. And we need to figure out how to fire fire in our energy system. So that means replacing those super hot things like a typical methane natural gas flame burns at 3,600 degrees Fahrenheit, and we're using it to cook and to boil water and to heat our homes. And none of those things do we want it to be 3,600 degrees. So if we can replace that flame with something cooler, that's almost certainly going to reduce emissions and ultimately also reduce cost. Yeah.
I cannot believe I forgot because I was facilitating. Typically, I would be the person who would have written a very short little evaluation.
Oh, geez.
I will do something short, but I will email it to
Yeah.
you because we'd like to demonstrate that, you know, this is a worthwhile endeavor. Or if you don't think it's a worthwhile endeavor, fine.
One that I'll send out probably on Monday. If you want to send me any questions, want me to add, I can just add it in.
That would be great, so they don't have to do two things. Can you, if you send it to me, then I'll see what questions you're asking. It might be
Okay.
just the same that I usually ask.
Sounds good.
Boy, do I feel like I missed that one. I just want to again, thank everyone for being here and, you know, there's a half-hour break, get your thinking cap on for those Funding Friday posters. And it's really low tech. It's just a great big sheet of paper, you know, those sticky note type poster paper and markers, colored markers. And you have that one sheet, I think, as you saw in the poster session, and I had it on one of those that, you know, what people have done in the past before for the Funding Friday. Think about including just a tiny bit of a budget. People kind of want to know, you only have 2 minutes to sell it to people, your pitch, but you do want to have something on there that shows, what you're gonna spend the money on. So just a tiny little budget kind of, it doesn't even have to have numbers. Most people do pictures.
Have to be ready for tomorrow morning.
It does. Tonight typically, although I don't know, last year they were kind of flexible because some people weren't done. And so I said, can I take it to my room? And they said, but it has to be up before, like, they have to start right away at 8:30, I think, or 8, yeah. Right away at 8 because they want to get all those pitches quickly done. Yep, you're gonna pitch it at 8 and then you guys will be leaving after the pitch. I will be in the room. Technically, you're supposed to be in the room, but I'll be in the room and I will text Lauren to let you know who gets the, you know, the funding. And if all goes well, they'll get 3 awards to for teacher.
They said students and teachers, so I don't know if there are students too.
She was gonna split that, but
Okay.
maybe she didn't
I
this year.
This morning that it was 3 for teachers and students, so.
Okay,
it's not-
so that would be like, graduate students here, a handful, yeah. I think so, yeah. And then there's I don't know what I am, but I said, I got thrown into I got told, do you want to be in the teacher one? I'm like, I don't want to compete against you guys last year. So I'm like, no, this is then I'm with all the people that are talking about.
Part of it, guys.
Yeah, well, there you go. Yeah, no,
Me too.
what's that?
Me too.
Yeah, yeah. So, but my one is getting data into the hands of students. I'm gonna talk about the
Sounds like
cube.
Carla and Don. Do that.
Yeah, well, Don won't. be
Yeah, I'll be
here,
on
so
an
I'll have to
airplane.
pitch it.
She said.
That's true. I am gonna mention AGI.
Mention AGI, feel free. I'd
Yeah.
like to mention AGI.
Yeah.
I will be getting a rental car.
That's right, but I will mention AGI as the dissemination
Need a
thing.
collaborator, AGI, I'm happy to collaborate. Perfect.
Yeah.
Love it. Yeah. We're happy to
So-
collaborate, whatever way we can.
And I threw up another slide that I intended to get to earlier, but I mentioned it, about scaring people the right amount. So hyperarousal means you can't calm down, you're freaked out. Hypoarousal is you're shutting down, you're depressed, you're lethargic and can't do anything because of that. So you want to, you want people to be in the window of tolerance where they understand the problem, they're worried about the problem, but they're not totally freaked out or totally shut down, and they can actually work on the problem and not be depressed or anxious too much.
Here's a bingo for like social algorithms where it's like, my mom is worried about everything.
Uh-huh.
Her phone gives her more things to worry about.
Yeah,
And it just ups her hyperarousal. And I
Yeah.
bet it was just like feeding her worrisome things.
Yep.
And I wish there was a way to be like, the world is sleeping.
Connect-
Kids are okay.
Is she worried
Run
about?
down To the window of top.
Yeah. Well, get her in, third act, maybe. Do you know what third act is? Yes, please. Unless you want them. If you want them, you can certainly take them. Yeah.
the National City Education Development Project, I don't know if they have these in like parts, but we think that would be a great thing to collaborate on, but you
Yeah.
could be like,
Yeah.
here's an activity.
Yeah. So third act is for retired folks to get involved in working on climate change stuff. And so it's connecting to a community. It's working on the problem. So rather than just being freaked out, get together with people who are working on the problem and you'll feel better. Yeah. Yeah.
Think for like the climate.
Yeah,
it's
yeah.
Like Chicago, you know.
Yeah.
All the things.
All the things.
Yeah.
Yeah.
Disaster.
Yep. She's not wrong.
No, that's a problem. It's like, but you, at some point, you gotta stop working people up and
Yeah.
One year.
not gonna have any.
Pay $100
because I was 10 pounds over and I knew if I opened my suitcase, I would never get it shut. I had jammed it so,
Wow.
yeah, so I was like, okay. fine.
And if anybody wants bookmarks to share on 3 sources, I've got lots of them.
Yeah.
Pardon me? And there are 2 flavors.
Flavors, one, some for each flavor. Free book
Carla, do you have the survey from last year? Because I can just add that and add questions, because ours is pretty general.
Probably, I will need the data to
Sure
look
thing. Thank
for
you.
it
Yeah.
and remember.
I'm gonna send this out.
Great meeting y'all.
Yes, me.
No, absolutely.
We don't come back.
Oh,
I would like to.
yeah, we're done in this room.
Okay.
Um,
I just need, yeah, like tomorrow I am here. I'm not flying back until Saturday. So I'm here staying through the meeting and then I'll, or even during some of the, if there's a business meeting, I just kind of look like I'm really paying attention, but yeah, I do that then.
We're done with this room. I think Funny Fridays and.
It's downstairs in the lobby bar area, and I think they will have some food. Usually they provide some kind of appetizers. Yeah,
And
typically.
then, tomorrow morning, we'll be down in the basement. I think,
Can I take a
for
cue?
potato starters.
Oh, yeah. You
I
get cute
made
too.
cards.
But it gets cute. I was making some extras so I could share with the
I'm excited for
piece
you
of
all.
group at large. Do you want to take
You
an
guys
ice?
could help though.
Sure.
Okay.
Sure, Carla takes pictures. Carla, we were taking pictures tomorrow of Funny Friday.
Yes, I take a picture of each one of the
Perfect.
posters.
Perfect.
Yep.
And then I'll meet you guys there. When I get in the car, I'll come in and then we're gonna like, jet out real quick. Have your bags packed in the morning. You don't have to bring them. You don't have to do it. Well, you would, yeah, you'll want to do checkout before 8 o'clock. 'Cause it took forever. It took forever just to even talk to something. So I would check out in the morning, and then bring your suitcase downstairs, and then we're gonna leave right away, Funny Friday, and get going this car, if you wanna be there first night there. Action packed early morning. Getting you guys back to your regular time.
No one gets done.
Yeah.
Yeah, exactly.
Oh, sorry, John. I was like thinking, maybe I should let them know. You have 5 minutes left. Okay. Okay, guys, we'll see you there shortly and we can dump whatever ideas you want.
Yeah, I have to go. Yeah, and then I'll be down, so not at right at 6, but yeah.
Okay, what else? What
Enjoy it.
Thank you so much, and thanks for being, kind of last minute flexible with me. I just,